There's a farmhouse kitchen outside Bergen, Norway, where a pot of salt cod and barley has been sitting in a wooden box since early morning. No fire, no electricity, no heat source of any kind. And at 7 in the evening, that pot reads above 165 degrees Fahrenheit on a probe thermometer. Not warm, hot. The science behind that number is not complicated, but the fact that almost nobody in the modern world knows it exists is the part worth your full attention tonight. The device is called a Fireless Cooker, built from hay, wool, sawdust, crumpled newspaper, straw, and cork. Used in Norwegian farmhouses since at least the 1860s, standard equipment in British working-class homes by 1910. During the Second World War, the Finnish government issued official instructions for building one from household materials as part of wartime fuel rationing. A study by the Norwegian Technical University in 1953 found that households using retained heat cookers consume between 55 and 70% less cooking fuel than households using conventional stovetop methods for identical meals. That study was never translated into English. Nobody with a financial stake in selling electric ranges had any reason to fund a translation. The physics explain everything. When you heat a dense mass of food inside a heavy vessel and surround that vessel with a thick layer of insulating material, the heat already stored inside the food continues the work of cooking. A 2-gallon pot brought to a full boil and sealed inside a well-insulated box will hold above 170 degrees Fahrenheit for up to 14 hours, depending on insulation quality and vessel mass. The food does not stop cooking when the flame goes out. It keeps cooking slowly, gently, without the aggressive heat that destroys texture and drives off moisture. Any trained chef would immediately recognize the result. Here is where the history becomes uncomfortable. In 1912, the Boston Cooking School magazine published a 4-page feature calling the Fireless Cooker one of the most practical advances in domestic economy available to American households. By 1920, Fireless Cooker kits were being sold by Sears Roebuck for $3.50, roughly $90 today, with tens of thousands of units moving annually across the Midwest and South. Working families started a pot of beans before factory shifts and returned home to a finished meal. Then something changed, not suddenly, quietly. Between 1925 and 1940, the major electric appliance manufacturers began a coordinated campaign traceable through archived trade publications and land-grant university records. University extension services across 14 states began receiving curriculum funding from appliance industry consortiums in the late 1930s. Home economics textbooks published between 1938 and 1945 systematically removed fireless cooker instructions that had appeared in earlier editions. The erasure was bureaucratic, one revised edition at a time. By 1950, the fireless cooker had nearly vanished from American domestic life. Not because it failed, not because something better replaced it, because it was incompatible with a grid-dependent economy that needed every household running a meter. In Norway and Finland, where electrification moved more slowly, the device survived. In 1967, a Norwegian agricultural cooperative documented 14 distinct regional variations still in use across Telemark and Hordaland counties. The simplest was a wooden crate lined with 4 inches of compressed wool. The most refined was a double-walled zinc box with a cork fill layer of exactly 3.5 inches, produced by a craftsman in the village of Voss since 1931, and still sold in 1967 for the equivalent of 11 American dollars. Building one today costs between $18 and $35. You need an outer box of 3/4-inch plywood, interior dimensions of at least 20 by 20 by 16 inches. Inside, you build a layer of insulation no less than 4 inches thick on every surface, including the lid. Compressed wool batting still performs best, holding heat roughly 40% longer than equivalent fiberglass. Rigid foam board, cut to fit and wrapped in aluminum foil on the interior face, costs around $8 for a full sheet. The foil reflects radiant heat back toward the pot. In the center, you form a nest, a shaped hollow just large enough to hold your vessel with no more than a 1/4-inch gap on any side. The vessel determines the outcome more than any other variable. A cast iron Dutch oven between 4 and 6 quarts is the standard choice. Cast iron holds heat approximately 3 times longer per pound than thin stainless steel. At modern retail, a cast iron Dutch oven runs around $60. The same piece from an estate sale or farm auction costs $8 to $15. The mass is what you're buying: thick walls, heavy lid. A cast iron pot at full boil stores enough thermal energy to cook actively for the first 2 hours inside the box and remain at safe serving temperature for up to 12 additional hours. A thin aluminum pot under identical insulation drops below safe holding temperature in under 3 hours. The foods that respond best all share one characteristic: they improve with time. Dried legumes, whole grains, tough collagen-rich cuts, root vegetable stews, overnight grain porridges. All become noticeably better after 10 to 12 hours of gentle, sustained heat than after 3 hours of stovetop cooking. The collagen in a beef shank converts to gelatin around 160 degrees Fahrenheit. In a conventional pot, you fight to hold that temperature without exceeding it and shredding the fibers. In a fireless cooker, the temperature curve naturally descends through exactly that conversion range over several hours, extracting gelatin continuously without turbulence. Same recipe, different physics, different result. The variation almost nobody discusses today is documented in a 1908 Swedish household manual held in the Uppsala University Library. The author, a domestic science instructor named Ingrid Carlson, describes lining the interior nest with compressed wool and then a secondary layer of fine milled rye bran packed into cloth bags arranged around the cooking vessel. Rye bran carries a specific heat capacity nearly double that of air and comparable to dry sand, absorbing heat from the pot in the first phase and releasing it slowly over the following hours. Carlson reported this dual layer system extended effective cooking temperature by 90 minutes beyond wool insulation alone. Her manual went through 4 printings between 1908 and 1921, never translated into English. If you grew up in a house where someone slow cooked without watching, where a meal was left alone for hours and tasted better for it, that person understood something 3 generations of appliance advertising worked hard to erase. Maybe they called it a hay box. Maybe they called it a wonder cooker, which was the commercial name used by a British manufacturer in Manchester from 1903 until 1941. Maybe it had no name. Just a wrapped pot pushed to a closet while the family worked. Whatever the name, the principle was identical. Heat stored is heat used. What else has been quietly set aside because it made the meter unnecessary? That is the question Secret End Solutions keeps returning to, one technique at a time. Tell me in the comments whether someone in your family ever cooked this way. Not with a kit or a recipe, just a pot and insulation and the knowledge that captured heat does not need to be wasted. Subscribe, because the next investigation concerns a ventilation method developed on Norwegian fishing vessels in the 1880s that kept food cold without ice using wind direction and copper tubing, documented in a 1903 Maritime Engineering Journal and quietly removed from circulation when the first electric refrigerator patents were filed. You will want to see that. Sonnet 4.6.